What's up, universe? Elliot from Starforge Systems here. A computer's central processing unit, or CPU, is responsible for the core functionality of the computer. It performs all of the functions input by the user through software and external devices to achieve an output. At the smallest level, this looks like a great deal of math. What allows the computer to do this math is a variety of factors that total its performance. Those factors are architecture, which is how the processor is designed, making it more efficient and capable of doing more per cycle; clock speed, which is the rate at which a processor computes, usually measured in gigahertz, with instructions performed in each cycle; cores, which are workers within a processor that help a processor execute multiple operations at once. More cores generally means that the processor is better at multitasking. And the focus of this video, cache. Cache is dedicated memory physically attached to the processor itself. This memory is incredibly fast, and the fact that it's local to the processor and its cores helps in reducing latency. Cache can be broken down into different levels. L1 cache, which is directly accessible to the CPU, usually handles data actively being processed. L2 cache is often core-specific, and it stores data about to be processed. And L3 cache, which is shared across cores, streamlining the processing of data between those cores. The more data that can be held in each of those levels, the faster and more efficient the processor is. While each of these are important to a processor's performance, there's something unique that AMD has done in recent generations to drastically improve the performance of their processors. 3D V-Cache first debuted with the Ryzen 5000 Series X processors and instantly had these CPUs outperforming the competition. By stacking the CCD, the part of the processor where its cores live, on top of its cache, the amount of L3 cache accessible to these processors is increased significantly. This means that whatever core is under load, or if there are multiple cores under load, they have the ability to store more information and data in this readily accessible, extremely fast memory. With there being obvious downsides to having reduced cache, the innovation that is AMD's 3D V-Cache starts to matter more and more. Not every gamer is going to realize that sometimes their drops in frame rates are because their processor is constantly having to access data that's just not immediately accessible to the CPU and its cores as it could be. Which is why we here at Starforge are proud to offer multiple X3D processors in our lines of computers. The Navigator III Elite, like the one behind me, features the 7800 X3D that will be the focus of our testing. But keep in mind, we also have current X3D processors in our Voyager line systems. Of course, it's easy to write off a processor from a previous generation as being slow and not worth continuing to build with. But the fact of the matter is, that's just not true. The 7800 X3D, while it draws a bit more power than its cousin, the 7700X, is still light years ahead of an already solid processor. What's more is that it even competes with and outshines current-gen processors like the 9700X. Heck, it's even capable of beating the other guys. We've built some identical systems to put our money where our mouth is and demonstrate just how great these X3D processors are. These systems are going to be running through some built-in gaming benchmarks, as well as recording some footage from actual gameplay. By using some capturing software, we can live report what FPS each system outputs. Remember that these are identical systems outside of the processor. While some Counter-Strike 2 plays in the background, highlighting the differences in FPS on identical maps on these nearly identical systems, it's worth noting that we've changed up some of the settings for these tests. For each game, instead of its highest settings, we've swapped to balanced or medium presets to maximize frame rates. Black Ops 6 begins our testing suite. Not only does the 7800 X3D have a slight edge over the 9700X in average FPS, totaling about 3.5%, it beats out the 7700X by almost 8%. But where the X3D CPU gains the most is in maximizing lows. The 1% lows for our X3D CPU were just under 6% higher than those of the 9700X, but were a whopping 85% better than the 7700X. On to F1, the 7800 X3D averaged 595 FPS, a roughly 6.5% improvement over the 559 FPS average for the 9700X. The 7700X, from the same generation as the 7800 X3D, which comes stock in our Navigator III Elite systems, falls rather far behind, averaging 445 FPS and giving the 7800 X3D a 34% advantage. And lastly, we brought back Cyberpunk 2077 to pit these CPUs against one another. The 7800 X3D averaged 438 FPS across our 5 testing passes, beating out the 7700X's 369 FPS by a little over 18.5%. Bear in mind that because the 7700X has a higher core and boost clock than the 7800 X3D, this difference is entirely based in the increase of L3 cache. What's more impressive is that even with a generational improvement in architecture, the 9700X still only ran at 385 FPS average, giving the older 3D V-Cache CPU an almost 14% advantage.
Pretty incredible stuff, huh? We're thrilled to have partnered with AMD for this video and are even more excited about what these X3D processors can do for gamers. If you're ready for one yourself, check out the Navigator III Elite available on our website. Thanks to AMD, this system, which pairs a Ryzen 7 7800 X3D with a Radeon RX 9070 XT, is marked down through Cyber Monday. For yours, check out starforgesystems.com and click the link in the description. Thanks for watching, and I'll see you in the Forge.